Hello, welcome to another day of the Internet Measurement Village. Joining us today is Joe Manco, an analyst from Psiphon, who'll be telling us all about circumventing internet censorship with Psiphon. Thank you for joining us today, Joe.
Hello, morning village people. It's great to be here in the Universe. Hope everyone's been keeping well these unique times. So I'm here to speak to you about Psiphon and the Psiphon data engine, one of our new projects. I'm Joe Manco, one of the analysts here at Psiphon in Toronto, Canada. We build tools and technology for anti-censorship and maintain a circumvention network that supports millions of internet users accessing the internet from censored networks. Today, on average, that's anywhere between 3 to 5 million unique users each day all around the world. Psiphon was originally created out of the Citizen Lab at University of Toronto in 2006. And the goal was very simple: to provide recourse against online information control to people accessing the internet from censored networks. And our objective and our mandate is to provide simple to use, effective, and free tools that are accessible worldwide. The core principles of the network being, number one, provide reliable access to content and attention to the speed and performance thereof. And two, protecting user privacy. And to make these tools as accessible as possible, we prioritize local language support and localization. We're very thankful for the invaluable work of community translators and groups like the Localization Lab in this area. And as well, we support and collaborate with numerous local partners such as media and civil society organizations. This is just a brief timeline to show the changing needs in circumvention, and especially the growing need for such tools and technologies in the face of continually improving hardware and software that's used to control content and traffic online, and as well the changing nature of internet usage itself, specifically the scale of that demand, changing the way that we need to design the system to accommodate the large number of Psiphon users that we support today. So Psiphon, like many great software projects of that generation, it was started in a basement in 2006. The initial design was a peer-to-peer model. It was designed to allow friends and family to act as nodes in the network and proxy traffic of other users through your system. Essentially used among diaspora communities predominantly, as well as some Canadians that wanted to help provide access to the open internet. And in this way, this was spread by word of mouth. Personal referrals, I would say, is still the main method that people do come across our apps. But as it began to reach a size where the peer-to-peer network was encountering issues of scaling, Psiphon 2, which was a network of web proxies, basically a managed system of web rewriting proxies, was created, and it was much more scalable. Today, this is still kind of a legacy system, but it's still maintained and it remains rather popular today. But likewise, the technology underlying Psiphon 2 faced similar challenges with scalability. It lacks the same level of blocking resilience, and it has the limitation of being browser only. So as the online experience began to migrate to mobile devices and become much more app-based, we needed solutions that were capable of tunneling all the traffic from the device, which today's generation, we have the Psiphon 3 apps, which is the mobile and desktop clients, which is where you will see the majority of users these days, iOS being the most recently added in 2017. So the client software is designed to be lightweight, downloadable from many different app stores, web mirrors, email addresses, etc. Be super simple, free, localized, and therefore as widely applicable to many, many different people in different contexts around the world. And so this is a map that shows the distribution of Psiphon users across all these different countries. And throughout this talk, I will get into how and why reaching this kind of scale does facilitate this sort of measurement of the global censorship ecosystem. And also, all the technology we create is open source. That means that there's transparency in the code base and regular, robust peer review of our tools. So it's under the GPL, and it's free software in that sense of the word. How content is controlled online is via an array of different techniques and methods that are based on ISPs as a vantage point, or ISPs or other network operators as a vantage point over the internet, and hardware and software that's used to enforce different blocking rules. These were already explained in some of the previous talks, such as Maria from OONI's talk on the first day, showing the various vectors of filtering that can be enforced on internet traffic. And one technique that's become quite prevalent today is sometimes referred to as traffic fingerprinting, which allows sensors to create a record of what browsing sessions look like and create rules for those that can be leveraged at even HTTPS traffic and other encrypted forms of traffic like VPN or SSH fairly easily. So this kind of interference is typically done using deep packet inspection or DPI technology, and it can be and is leveraged even at circumvention tools directly. And of course, certain ports or entire protocols can be restricted by sensors. So this capability, it represents a prevalent threat to the effectiveness of many circumvention tools, and especially single protocol VPN tools, which is part of the reason these techniques need to continually evolve in this highly dynamic and complex environment. So Psiphon is designed to be, as I said, an all-purpose circumvention tool. It's designed to be efficient in the selection of connection methods, but resilient within the multi-protocol architecture of the transports that it uses. We operate an adaptive network that can shift based on the filtering techniques that are deployed. And we deploy a number of different circumvention protocols and various traffic obfuscation methods to provide the most reliable anti-censorship possible. And that's regardless of the user's location or what methods of interception are deployed on those networks. And as I mentioned, there's an advantage to such protocols not standing out on the network as some strange encrypted thing, but rather to resemble as closely as possible the most common types of web traffic, or to be relatively indistinguishable from those. So the use of Psiphon is very simple. You open the app and click connect. The client is going to determine where you are connecting from via a GeoIP lookup. It allows Psiphon to generate a prioritized list of connection methods based on your region. And it will cycle through those until a viable connection can be established. So Psiphon, the client, will diagnose the fastest connection available to you based on your local network conditions, and you will be tunneled via the appropriate Psiphon server and transport. So with the changing and often very fluid censorship environment, there's an increased need for such flexibility, an ephemeral network, and an adaptive, transmutable protocol structure. And in general, the transports that we use at scale, they need to demonstrate effectiveness, resilience to blocking, low overhead, and to not place undue demand on users themselves. So, I mean, a simple diagram, but shows you're going around the block channel to the Psiphon network and then to the internet. And maybe going through one of the small holes in the fence is a more appropriate analogy than going completely over it. So what are the network analytics that are generated from this? Our stats are derived from collecting aggregated network data only, that is, not collecting personally identifiable information such as IP addresses. And Psiphon collects no data that could be traced back to individual users. So, and that's all explained in the privacy policy posted to our website. And we use this data to monitor network performance, allows us to ensure that the network is functioning effectively and identify how changes in the technical environment and in the socio-political dynamics of censorship is impacting our network traffic. So some of those metrics, I already mentioned unique users. We have in the top left the number of tunnels connected. So that is the number of network connections that were established. We look at bytes transferred, which is throughput, a very important metric of network performance. Also tells us about the volume of usage and even the intensity of usage when you look at it as a function of the number of unique users. In the bottom left is showing establishment duration. So that is how long does it take between the time that you press connect and the establishment of a connection to the network. So you can see the vast majority of users are connected within under 10 seconds, most of them pretty much immediately. And any inversion in this statistic, it might be an indication of interference, either that those servers are not completely available or those protocols are not completely available, increasing the amount of time it takes to the network to find a viable connection. And then lastly, the duration of tunnels. So how long does your session actually last? It's obviously another very important indicator of session quality. Are people able to stay connected, or are there cases of forced termination of long-lived connections, as we've seen deployed in some environments? So that's a way of keeping an eye on the network health. And I'm going to go through just a few very, very quick case studies to show times that this network has been relevant and the scale of usage and the effects that that blocking has had. So this is a case from Iran in late 2017, where the government blocked Telegram Messenger, and it was estimated to have at that time, I think, 40 million users or something within Iran. And as soon as the blocking began, there was a surge of users to the Psiphon network, peaking at almost 14 million users a day. And we were pushing 1.5 petabytes of data from Iran at the peak. And this shows you the scale of adoption. It was very rapid adoption of our apps on pretty much all platforms, and a total of 5 million new downloads over the course of that period. It was a pretty unprecedented circumvention response as far as up till that point in our history. This shows another example of protests that occurred in Sudan, which were responded to by blocking social media and messaging apps. So it started in December 2018. And this is an interesting case because it highlights the effects of economic sanctions on the availability of tools. So the Hack66 group, they posted a repository that allows you to kind of canvas the app stores for the availability of different tools. And in comparing the Sudan App Store and Google Play Store to the US ones, we found that many of the VPN options, which require kind of a subscription or at least like entering credit card information, they're not able to be offered in the Sudan stores. So showing that there's a limit on what tools can be made available in these circumstances. This was also a very successful case of word of mouth promotion, especially by CSOs and advocacy organizations such as the Access Now digital helpline, make it as basically a key link to end users being able to discover the app. And here on this visualization, you can see 2 periods of blocking. You can see the adoption relatively slow on the first curve, and then the second blocking event, which occurred in April. Obviously, the response, you can see the deployment or the seeded community of Psiphon users was able to respond much more quickly the second time. And then here again, it shows that later that year, there was a complete blackout of mobile internet for around a month. And the day that the internet came back on, basically, everyone instantly returned to our network. So this is another, this example is interesting because there were no Psiphon users in Sudan before this. And there had been no instances of censorship on this scale of sort of apps and social media that are widely adopted in this way. And the same thing happened in Syria last May, starting last May, with the filtering of WhatsApp, which WhatsApp to Syrians is like what Telegram was for Iranians. And this persisted until just about the end of March of this year. One thing that's interesting about this case was it revealed some of the limitations of measurement tools, censorship measurement tools, because the OONI WhatsApp test was actually revealing that the endpoints of WhatsApp were reachable from Syrian networks. But so it was kind of difficult to attribute this surge in usage to particular blocking. There's always challenges of attribution. But one thing that we noticed was the latency on many of these tests. Sometimes it was taking 30 or even 60 seconds to ping the endpoints. And what was anecdotally reported was actually WhatsApp was being throttled, or connections to WhatsApp were being degraded in such a way that prevented making voice or video calls. So that's, again, another interesting case where the deployment of Psiphon, it did really reach a relevant population scale. So that's a good segue into the data that's contained here, which is our new public dashboard, the Psiphon data engine. And I encourage you to check out the website that's there. I'm going to show you a couple of things that you can find there, and then hopefully I'll leave most of the time available for discussion. So the PDE is an open data platform. It's an initiative that was formed based on reciprocal data sharing partnerships, and it allows us to gain a more comprehensive understanding of the censorship landscape by comparing data across indices, across measurement platforms, and help to corroborate and attribute network events. So this is what you will see if you go to the site. Hopefully my screen is still sharing. We've incorporated here data from OONI and MLab. OONI showing obviously the availability or inaccessibility of different web platforms and messaging apps. And MLab showing data on basically from their NDT speed test results, showing data on network speed and performance. So we can correlate these two different types of blocking events. The way that across these three indicators, the blocking of a popular platform is going to manifest is going to be different than the way that, say, an internet outage might appear. So you can drill down into the data here. In the case of the Iran data, you'll also see our open source intelligence annotations, basically like weekly documentation of the news from the ICT landscape over that time. And you can, over the long term, sort of compare the changes in usage with some of the events that have gone on. And on a regional level, you're able to check out any country and delve more deeply into the data. So here, just as an example, is showing Russia. You can see the scale of Psiphon usage in relation to the types of sites that sites or platforms that are blocked. In a couple days' time, when the data is populated, you're probably going to start to see Telegram move from the blocked column to the available column within Russia as of yesterday's news. So this is a really great initiative. It's a way of harmonizing potentially disparate sources of data that's not in a common format, data that's not like there has been so much success with advancing the measurement systems that we now rely on for this type of research. They've come a long way, and it's fantastic now what we're able to do in a much shorter amount of time. Obviously, this is an achievement to try and make things as accessible as possible for researchers. You can access all this data, you can download it, you can utilize it without having to write a database query. As well, if you're someone who's running a censorship measurement system, but maybe your data, you don't have time to do the pipeline work, or your data exists simply in the form of some random JSON files, then this is a way to have that quickly and easily visualized. So we really do encourage more partners to join this project, join this initiative with us, and contribute data here. And what we hope to do, or hope to work towards, is basically coming up with different types of fingerprints for these events. So I want to talk a little bit about forecasting and anomaly detection before I close out. But the idea is that on these data feeds, a process can run, which is looking at all these different indicators and can actually flag an alert when there's a change in the seasonality of the data feed. So here in the green is what actually happened, and in the yellow is what the prediction engine forecasted would happen. And you can see that the forecasting is very accurate. So we're able to predict even 48 hours into the future what the numbers might look like. And as we start to integrate different data sources, that type of forecasting and anomaly detection will become even more robust. So yes, as I said, we encourage anyone who's collecting data on the censorship environment that would like to see your data housed in this repository, or any questions that you might want to ask, you can contact us here at this address, pde@psiphon.ca. And that's about all I have to discuss. I'd like to leave most of the time, if I can, for discussion or question and answer. So please put your questions, comments in the pad or in the YouTube channel, or however else they can be received.
Thank you, Joe, for that presentation. It was very interesting, and we've gotten quite a few comments coming from people that were following this presentation on the internet. I would encourage people that have more questions to leave them in the chat under the video, on the OONI Slack channel, or on IRC. Or even the pad link that you see on your screen now. So I guess I'll just read some of the comments that have come in. So and maybe if you want to reply to them or address them. So one comment comes from Norman Angel, and their comment is, one of the most used tools in my country, Uganda, from 2018, after the government imposing a daily social media tax of 200 UGX, or 0.05 US dollars, for anyone in the country trying to access social media platforms. And goes on to add, many users did not only use it for data anonymization, but rather to bypass the internet censorship, i.e. the social media tax in the country, which is still in existence to date.
That's an interesting comment. Definitely, yeah, it's a bit of a unique new case, because we often overlook the economic dimensions of censorship online in favor of the sometimes more obvious political or social motivations.
Yeah.
As well, in Uganda, there was, during the elections, the most recent elections, as well as in 2016, control over social media and messaging apps, which resulted in a similar surge in Psiphon users to the ones that I've shown here. I think there may be some information on our blog about one of those cases.
Interesting. Another comment that we have comes from Simona, and it's in relation to, I guess, the topic of measuring instant messaging apps blocking. And he says, this is more of a comment than a question, the complexity of measuring IM apps is that it's difficult to get them on board helping us in measuring them. For example, we have an experiment that measures whether Psiphon is working. And this has been possible because of good collaboration between OONI and Psiphon, as well as Psiphon being based on a technology, Golang, that we can easily integrate. And so, he goes on to say, with a minimum degree of collaboration from IM apps makers, it's rather difficult for us to better our IM measurements.
That's interesting. I mean, I'm sure we can discuss this more out of band, but I think so. I mean, I only mentioned that with the Syria case because of the limitation of the test, that it's trying to contact the three endpoints, the whatever the application service, WhatsApp web, and then the registration server. And it's one thing to send basically what's essentially a ping that may not trigger the censoring behavior of the Syrian firewall, but sending a payload that's more of a closer simulation to what it's actually like to be sending a message or a call. I think that would be a very valuable addition to those metrics.
Yeah, exactly. Yeah, I think how you you explain it is pretty accurate. Like, I guess our challenge is that, though, you know, we sort of tried to implement the test the best that we could, given the fact that there's not really much collaboration on the other side. So you know, it's very hard for us without engaging directly the developers of the tool itself to fully reproduce their protocol. Especially in the case of WhatsApp, which is like a closed source protocol. And so, you know, basically, there's only so much that we can do. And in the case of WhatsApp, you know, I guess we went for sort of the like a basic approach of just being able to yeah, basically ping the things, just do a reachability of the endpoints and see if they are being blocked at that basic level or not.
Which probably works for most of the less nuanced forms of filtering. The issue of voice over IP blocking within the MENA region and the Gulf countries in particular is interesting, because I believe that WhatsApp actually they may send voice and video over different ports than they send the rest of the traffic, like text and media messaging, possibly presenting an easier vector for countries to restrict only certain types of messages, like calling, but still allow like the general use of SMS. So I'm not sure if that's something that's been completely looked into, but it's potentially an interesting area of future study.
Yeah, that's true. Generally, the signaling channel, like the one that you would use to, I don't know, either communicate metadata about call establishment or what have you, or even sending like text-based messages or data payloads, is generally yeah, distinct from that which is used for streaming voice and video. But yeah, I guess I will use this opportunity to make a you know, a request out if there's any instant messaging app developers out there interested in helping us out in bettering our tests. Please do reach out to us. We're definitely very much excited and interested and keen in collaborating with you. And similarly to how we worked and collaborated with Psiphon, and now we have a very nice Psiphon test, which in fact works somewhat very similarly and very close to what like how Psiphon actually works. So yeah, we would like to do the same for other tools as well. So do reach out to us.
Great. Yeah, that's an amazing accomplishment, and hopefully we can see more of the circumvention tool tests rolled out on OONI Probe soon.
Yeah. So we have another question that comes from Shenyang, and she asks, in the figure, global tunnel connections, there is an obvious pattern. By any chance, have you checked why there are constant spikes over time?
I believe the visualization that that it's referring to, or that I showed, was basically showing hourly connections over a week or 10 days time.
I can pull it up. I think it's this one.
Okay, great. Thank you. So, yeah. Okay, this could be a tiny bit misleading, because it seems that the day aggregation, it occurs at the same time every day, and it could be a spike because of that. If you go down to Arturo,
down some slides
to the forecasting one, I'll explain it based on this. So this is what a day's data would look like normally. People being asleep at night, and sort of, you know, gradually waking up in the morning, taking a break for lunch at midday, and so on. This is what I would say is a completely normal pattern. So those spikes correspond to basically peak usage times during the day.
Right. Yeah, that makes sense. So we have another question coming from IRC. Ivan asks, could you talk about some of the techniques you use to avoid traffic fingerprinting?
Yeah, I can say a little bit about that. So I think, as noted, generally encrypted protocols are ones that get figured out over time by sensors. VPN being an example of one of those that's now fairly easily blockable by most off-the-shelf DPI boxes that can be acquired from the private sector. So, and just to hammer on the point of not standing out as some strange encrypted thing, it involves blending in with the regular web traffic that is permissible. And to do that, you have to think of the vectors. Basically, what are the vectors of attack on your traffic? So one of the I guess like doing things to randomize, changing the packet size, packet interval, adding random padding into the tunnel so that the proxy traffic looks like something else, whether that be web browsing or video streaming. Basically, like always trying to emulate the whitelisted types of internet traffic. There's also blocking based on SNI that you can be concerned about. So, like I think a recent paper showed that in China, even up to 30% of the blocking is SNI based. So there was, and I mean, those are some of the main ones. It really involves an analysis and a diagnosis of what's working, feeding that data back into our development processes, and making sure that the transports we use do not stay static, but that they're always changing, they're always evolving. It makes it, the less of a recognizable pattern in your randomness that you can have, then probably the more difficult time establishing a viable fingerprint for that traffic specifically is going to be. Another thing is there's always part of a transaction that's happening outside the encryption. That's the handshake, and so making sure that there's nothing immediately recognizable about the handshakes that you're using to actually start the encrypted tunnel. That's in broad strokes as much as I can say on that at the moment. But feel free to drop me a line if you'd like to discuss it more.
Right. And I guess you also make use of some of the pluggable transport techniques as well.
Yes, that's true. So there's a growing body of researchers who are working on new transports, which is amazing. And the Pluggable Transports project is trying to figure out how to operationalize those, take those out from an academic environment or research environment and make them deployable at scale, or at least testable at scale, and see what's going to be relevant for circumvention at scale. So that's a great project to point out. Another thing I think that's worth mentioning is the use of CDN infrastructure as a way of kind of getting around the most severe forms of censorship. So, that tends to be, for people that are unfamiliar, CDNs are content delivery networks. They're huge, very important infrastructure components of the internet that cache content between origin servers and the end users. So they're basically crucial for the speed and availability of online services like streaming, social media, e-commerce, and they're considered high-value domains, basically. So routing traffic through high-value domains, it provides added circumvention value because you can hide the traffic to the proxy inside these connections that are to legitimate websites. So you may have heard of that referred to as domain fronting in the past. So that's another technique that can be used.
Right. And somebody from IRC was sharing a link to the Psiphon GitHub code repository, which has also more information about the specific like obfuscation technologies, and the link you can find in the comments here. I'll read a few more comments for going on to other questions. Keep your questions coming. Well, people expressed a lot of excitement for both the numbers of Psiphon, saying that they're quite impressive. Also mentioning the Psiphon data engine at 6.ca looks very useful too for other censorship circumvention developers. Then DCF says Norman's question. So this was the question in relation to the Uganda social media tax is similar to what I heard from V2Ray developers, that some users use simple obfuscation like stapling a phony HTTP header to avoid protocol-specific throttling by ISPs.
That's very interesting.
So yeah, that's quite cool. So we have another question that comes from an anonymous user. They say, their ads are shown in Psiphon apps. Are they part of your business model? And then it goes on to say, you said Psiphon doesn't collect PII, but how about those ads?
The advertising that's shown in the I guess like iOS and Google Play channels, I mean, it makes a small contribution to our sustainability. Really not much. I wouldn't say that it's something that could be effectively leaned on as a business model, especially for tunnel traffic, where most ad networks, they want to get information on the users. So that's just something that we don't compromise on. I would say that there's the option of subscribing. Subscribers can help offset the network costs of all the free users. And the business model is really built on relationships with international broadcasters, those who do face challenges of censorship of their content. They have audiences that they need to reach abroad, and they have a mandate to support internet freedom around the world. So thanks to their support, which is crucial, organizations like the BBC, Deutsche Welle, the USAGM, Zamane, this is a way that we're able to still keep the network free for everyone.
Right. Cool. We have another question, comes from Simona. It's a long one. I'm going to take a breath. How is traffic routed inside the Psiphon network? Are there any policies applied to channels used by users? Is Psiphon using shaping or policing or policing? Have there been optimizations seeking to increase the performance and or reliability of streaming over Psiphon as opposed to bulk sending of data? Would the sending using packet pacing be better in terms of not loading the Psiphon network as opposed to sending bulk traffic? I know that Tor uses scheduling algorithms seeking to minimize queue sizes and be fair, and I was wondering whether Psiphon did any similar work in this space.
Would you mind sending me a link to the pad in the chat?
Sure.
Or
I can also send you the full question and also the link to the pad. But yeah, basically he's asking about how the routing, traffic routing works inside of the Psiphon network, and if there are specific policies that are being applied to, I guess, the traffic channels that that are used by particular users, and if it's done by means of traffic shaping versus by means of like policies being applied.
I see. The protocol selection that I mentioned is automated, and it's strictly designed to provide the best performance possible. It has pretty much no other loyalties than getting you the fastest connection that you can achieve from your local network. As far as the simple answer is it's a one-hop proxy. So you, from the client, have a secure tunnel to the server, and from the Psiphon server is going to be your vantage point of receiving the content from the internet through this tunnel. So to my knowledge, we don't make any special rules for the treatment of different types of traffic. Like, I don't think we even have any knowledge of the types of traffic that are being sent through the proxy, other than the protocols that we use. Like, anything on the user side is encrypted through the tunnel. I mean, you as a user can set your own rules. You can omit apps from the tunnel and things like that through. It's in the more options menu for Android. You can add exceptions to things that you don't want to go through the tunnel. Say it's not blocked, or you don't want to you want to make sure that you have crystal clear video call quality. Then you could make sure that your VoIP app was untunneled, for that purpose. But I will get back to Simona, because I think there's probably more to be said about this. That's just a little bit. I'm not 100% sure what more I can elaborate on that question.
Yeah, sure. That's we can follow up later.
Like, there's going to be different baseline levels of throughput based on what protocol the user is connected by. And some are more direct, and some, as I mentioned, are more evasive. And the evasive ones that have a couple more miles to travel, they might have also a higher latency or a lower throughput. That's to be expected. But there's no real, for us as a network operator, we're not giving preference to certain types of traffic. It's net neutral, you can say.
Okay, I see. Yeah, I think that's sort of addressing the question, perhaps. But if maybe if there's something more specific, you can either leave a follow-up question or follow up later. So we have another question that comes from Hussein. The question is: several of my friends in Iran have said that the Psiphon desktop app does not work well. Is there an option on the Psiphon data PSI? How do you pronounce it? PSIX 6? The Psiphon data engine dashboard.
There's not currently an option to sort by platform. I will say that so the client software, it doesn't make a huge difference, Hossein. Like, there's the Android client, the iOS client, the Windows client. They all use the same network infrastructure. But what you might encounter is different methods of filtering on the ADSL networks versus the mobile networks within Iran. And for sure, across some of the indicators that I mentioned when I was discussing the network analytics, we do certainly observe differences in performance based on that.
Yeah, because he was
as
asking
far as the pronunciation, Psyx.ca.
Psyx, okay, yeah. He was asking if it's possible to filter or display mobile and desktop traffic separately on the dashboard.
Not at this time, but that may in fact be a future development. So at this point, it just shows all traffic from the country at a sort of region level at the moment.
Right. Okay. Another question comes from Federico. And he says, the work put into developing obfuscation can benefit other projects, example Tor. Do you consider providing Tor entry points on your proxies?
That's not something that has been brought up to me, but I'm sure it could be considered. I think that's best discussed in a separate conversation. But I'd love to talk to Federico and whomever else.
Nice. Yeah, that's a good
and I will say that the point of this platform, like we'd love all. I mean, the Tor metrics portal is great, and we use it, especially when we see protocol anomalies in our network. It's very often reflected in the transports that are used on Tor. You could see inflections between direct connections and Tor bridge users that often correspond to network changes that affect our traffic as well. So it would be great to speak with the Tor metrics team about integrating some of those data feeds to be housed here.
Cool. And the DCF on IRC says, I think this use case can be answered by starting Psiphon, then running Tor browser. The Tor bridge guard doesn't necessarily have to be operated on the same host as the Psiphon proxy server. That's a good point.
Okay, yeah. I mean, there is definitely the option of running Psiphon and Tor concurrently. Excuse me, concurrently, and tunneling your Tor connection through Psiphon. Maybe this would work in places like in China, where Tor is known to be sort of very filtered from the Great Firewall. Maybe this would provide some additional resilience to those connections. And it's not something that I've tried, but be interested to hear if that's effective.
Yeah. We have another question from Simona. He says, judging from your dependencies, you're using IETF quick draft 29 as implemented by github.com Lucas Clemente quick-go. Does Psiphon have statistics regarding how often quick works worldwide or is blocked? So that is the quick protocol.
I suppose. I mean, insofar as we have those type of metrics for all our network traffic, then yes, we could answer some of the same questions.
Mm-hmm. Okay. Then Federico asks, is Psiphon legally responsible for the clear text traffic exiting from the proxies? If yes, how does this tie into the aspect of not keeping logs?
I'm not sure if I know anything about the clear text issue, so I'm not in a great position to answer that. I can speak to the. So I don't know. No logging is a term that's thrown around a lot in the VPN space. It really depends on what you mean by that. I can't imagine it would be possible to run such a large network and ensure performance for all users with zero logging. Like we have a lot of stats which are logged, and those logs help us responsibly administer the network. Now, we don't have any logs on specific users. We don't have any information that can be traced back to a specific user. Suppose if there were like a legal inquiry, we would not possess information to be able to provide about particular persons that were on the network. So
yeah,
I will leave the kind of the legal responsibility part at that, to say that we don't possess anything of legal value in any way.
Yeah, I mean, I guess what it means is like you probably have something like an exit node, if you wish, like which is terminating traffic outside of the Psiphon network and reaching some content or some things that could be could pose legal liabilities to the entity that is running that service, that is then reaching that illicit content or performing some illicit action on the internet. And I guess the question is like, how does that tie into the the logging question of like.
Interesting. Well, I mean, we're not able to know what sites or services people are accessing through this proxy. So even though like our server might be contacting it, we've deliberately set this up in such a way that we don't know, we don't want to know, and we can't know where users are going through our network.
Mm-mm. Okay, I see. Okay, then we have another question from Simone. The question is, does Psiphon include logic to detect captive portals?
Have you ever encountered a captive portal from using Psiphon?
I mean, I guess the thing is like if you're in an airport and you switch on Psiphon, is Psiphon and you haven't like paid for the internet, is Psiphon able to
I see.
automatically figure out, yeah, you're actually still behind the captive portal?
It really depends. There's a lot of variation in those, and I mean, I encourage you to, as you're waiting for your next flight, try and mess around and see how you get through. I guess it can be done.
Yes. Okay.
But no, there's no active kind of detection of. There's nothing like that. The only detection is, do you have an internet connection? If you do, the connection sequence will start normally. If you don't, then Psiphon will tell you we're waiting for connectivity, and that's kind of that's the test, really.
Gotcha. So I guess it would probably flag a captive portal as like no internet, perhaps, maybe. I don't know.
If the captive portal requires you to authenticate before it lets you kind of out of that little sandbox, then you'll be diagnosed to not have a viable internet connection.
Got it. Okay, then we have some other questions from Simone. He asks, is there a list of Psiphon exit nodes? Are there cases of blocking by content providers based on, say, the IP address of said exit node?
No, there's no, at least not a publicly obtainable list of any Psiphon servers. And as I mentioned, the network is ephemeral. It's always in transition. It's always in a state of flux. Servers that get blocked, they're no longer useful. Like as in their IP address has been added to some blacklist. They lose circumvention value over time, and they need to be replaced with new ones. So any server that's no longer functioning adequately or well is going to inevitably be replaced by new servers. So I think basically a network of this scale, it's important to realize that the redundancy comes from the strength comes from having redundancy, and the fact that no one server or no one list of servers even is critical for the overall functioning and health of the network is one way that we can ensure that performance remains solid for everyone.
Right. And speaking of this, he follows up asking, how do you choose where to put your Psiphon servers? Do you monitor what are the most likely destinations and choose where it would be more smart to exit?
I think at the moment we have 24 or 25 available server regions. So it's widely distributed around the world. More and more have been added over time. I can remember a time when there were like 7 or 9. So there's quite a bit more geographic diversity in the servers that users are able to select. And obviously that geographically that does help with load balancing. And so the default setting in most Psiphon apps, in all the Psiphon clients, unless the user has changed it, is to be on best performance. So if you select a region, then you may be intentionally giving yourself less good performance based on like trying to go through somewhere that's farther away, for instance.
Right.
So, we try to have a good geographic diversity. We try to have well balanced in terms of where our sort of like higher volume, higher traffic zones are, and all with the goal of ensuring that that performance that performance is as good as possible. And obviously, these have to be positioned in open internet regions as well. So, like I know you can select, I think, India as a server region, but maybe that's a place that some sites that you actually want to access would be on the block list, or something like that. So you can even be tunneling to a place that has unintentionally harsher censorship conditions than where you are potentially.
Yeah.
And I think more and more regions will continue to be added to that. So it really is truly a global network.
Great, cool, very interesting. So I think that's about all the time we had for questions. Do you have any closing remarks or thoughts or things that you would like to share with the Internet Measurement Village community?
No, I just want to thank everyone for tuning in. Really appreciate your attention and your time. Great to see you out here over the global ocean. If you want, you can reach out to me. Would you mind putting my email address back up?
You want me to put it? We will be putting all of the links and information in the video description, so people will be able to find it there as well. But I just loaded the slide now.
Right. So as I mentioned, we encourage measurement platforms, circumvention tools. Please reach out, work with us on the PDE. If you're a civil society organization working in media, you want to find out more about how our tools can help you, please reach out. And our inbox is always open.
Great. So thank you so much for joining us, Joe Manco. Thank you to everybody who tuned in and joined us from the internet for another day of the Internet Measurement Village. I will remind you that we have another presentation scheduled for this Monday, the 22nd of June. It will be at the same time, 1400 UTC. It's going to be by Giulio Wano from Internet Sans Frontières on advocating against internet shutdowns in West Africa. I wish you all a great weekend and, have fun. Ciao.
Sick, dude.
We're still live.